Hi everyone, this is Soumava. I'm an actual IT analyst at AIG and a current data science graduate student at the University of Illinois at Urbana-Champaign. First and foremost, thank you Kennedy Institute for giving me opportunity to present a poster on my recent work related to object detection exercise using the model. In my first slide, I give a little bit of description about object detection. So object detection is nothing but a computer technology related to a collection of computer vision tasks such as image classification, object localization, and object detection. So for my project, I used a YOLO model, which is a very popular model right now because it achieves high accuracy while also being able to run real time. So the way these things work is that the YOLO model has an algorithm that only looks at once at the image in the sense that it requires only one forward propagation passed through the network to make prediction. So because of the one forward propagation logic, it's very fast and also it preserves the high accuracy. The next slide actually gives a little bit of overview of how this convolutional network diagram works within the model. It's similar to the other convolutional network diagram, which you already seen in some other deep learning exercise. So for my model, I used an input batch of images, which I run through the CNN model. And what it does, it basically provides an output of a list of bounding boxes along with the recognized class. So in that case, each bounding box has a representation of 6 numbers, and the last number is basically represents a class. And this class prediction determines whether that object belongs to a car, a person, a tree, or something else. In the third slide, I give a little bit of a description about how this probability extraction works, because obviously we are doing class prediction here. So we need to come up with a predictability score of the class so model can accurately predict the actual object type. So in that case, it always gives a kind of a class score. And sometimes what happens that we wind up getting a lot of bounding boxes. So in that case, the YOLO model needs to come up with a technique called non-max suppression and IU to get rid of some of the boxes with low scores. So when we get rid of those overlapping boxes, the model able to increase the predictability and it also improves the accuracy and it can predict the object correctly inside an image and a video. In the last slide, you can see that I basically provided few sample outputs, which I got it from my YOLO model. After running the YOLO model, I got 3 images, which were able to predict the location of cars, traffic lights, person, and far objects accurately. That's it. That basically brings me to an end of my presentation. If you find it informative, please visit my GitHub link as shown below. I do also have a YouTube video link where you can see how I transform all the object detected images into a video format. Thank you.